This is section 11.1, Introduction to Set Theory and Venn Diagrams for our probability unit. So first we have some definitions. A set is a collection of objects. We use a capital letter to define a set, and elements are listed within curly brackets. So let's do a couple examples. And then we are not classifying, so you can cross that part off. So we're just going to define each set. So number one, the set of states beginning with the letter O. So we can call that set O, use a capital O, and then just list them. So there's our three states. Number two, the set of prime numbers from 1 to 15. So remember, a prime number is a number that can only be divisible by itself and 1. So here is our prime numbers between 1 and 15. We can use a capital P to define that. Number three, the set of multiples of 3 that are odd and are between 1 and 22. So what I did is I just made a little note over here. What is our multiples of 3? So I wrote them all out, and then we just want the odd ones. So cross out any ones that are even, and there's our set. And we can use capital or M. You can use any letter to define a set. We do have some common things though. So a universal set contains all possible elements for a certain problem or situation. So a universal set, we usually denote it as U. If we have a complement of a set, so the complement of set A is all the elements in the universal set that are not in set A. So think of a complement as like the opposite. So here we have the universal set, and here we have set A. So if we want the complement of A, we want to just take all the numbers out of A, and what's left is the complement. Intersection of sets is an intersection of set A and B as the set of all elements that are in both A and B. So the intersection of set in A and B is denoted right here. So that's read as the intersection of A and B. So here's an example. Here's A, here's B, and when we want the intersection, we only want what they share. So the same thing that is between both of them. So they both have a 2, they both have a 10, and they both have a 17. Union of sets is when we want the set of all elements that are in A or B. So think OR, as long as the number is in one or the other. So here we have set A, here we have set B, so the union of them is everything. So a Venn diagram is a useful way of visualizing sets. We're going to shade the Venn diagram below to show each relationship and give the symbolic notation. So if we want the complement of A, we want all the stuff that's not in A. So that's why we're going to shade everything but A. Intersection of A and B, we want the stuff that they share. So right here, the crosses. And the union of A and B is when we want everything in A or B. So everything would be shaded. So here we have an example. Directions: label the Venn diagram with the information given each set, then define each set to the right. So U is whole numbers that are at most 8. So we have A is 2, 4, 5, 7, and B is 1, 4, 7. So first, when we fill in our Venn diagram, what you're going to do is you're going to take the numbers and fill them in. So 1 is in B, but not in A. 2 is in A, but not in B. They both have 4. A has 5, and they both have 7. So what are we missing? We have 1, 2, we don't have 3, so that's going to be in the universal set. 4, 5, 6, we don't have 6. We have 7, and we don't have 8. So for the complement of A, we want everything that's not in A. And that includes the universal set. So we do 1, 3, 6, 8, because we want to go in order from smallest to biggest. So here's A. So basically we want the rest. Complement of B. So we want everything not in B. So 2, 3, 5, 6, 8. So here's B. So we want everything that's left. The intersection of A and B. So what they share. So just 4 and 7. The union of A and B. So we want everything between A and B. So we do 1, 2, 4, 5, 7. And I don't know if I said this or not, but I can't remember. But when we are listing our sets, we always want to go from smallest to biggest. So as I did in these examples, we always start with the smallest number and put them in order. And that is it for today's notes.